Let's welcome Dr. Frederick von Saal, Professor Emeritus of Biological Sciences, University of Missouri, Columbia, Missouri, and Dr. Ailey Cohen, Integrated Rheumatology Associates, Princeton, New Jersey.
Hi, everybody. Thanks for having us. So pesticides, you've been hearing a lot about this on this presentation and then during this course of this webinar. I'm going to talk about my perspective as well as a clinician, a rheumatologist, an integrative medicine physician. So I wanted to start with this really kind of shocking slide, and shocking to me, about 10 years ago when I jumped out of my car to take a picture of this sign outside of my kids' daycare. And it was sort of the entree into my world of understanding environmental health, in particularly pesticides. And we know there's a plethora of pesticides in our environment, from organophosphate chemicals to carbamates to nicotinamides to glyphosate. We're going to be talking about some of this during this presentation. But this was my intro into the world of environmental health in many ways. So I also wanted to bring to the audience some perspective on other aspects of exposure. Where do we get exposed to pesticides? And so I made a list of some of the places that you may not have thought about. So for instance, we all are pretty aware that food has pesticides, certainly non-organic produce. It's also kept very nicely and tightly into animal fat. Many are light lipophilic chemicals. But we also have a great deal of pesticide exposure through drinking water, whether it's intentional with the addition of chlorine, ammonia, detergents to clean up water before it gets to homes and doesn't spread pestilence throughout communities from a public health perspective. But we have unintentional exposures, such as agricultural runoff, industrial runoff. And so we have the whole drinking water component that many people don't often think about. Collars of flea and tick, collars for animals and pets, flea and tick products, household bug sprays and fumigation services that we ask to come into our homes, ironically, lawn services where we track in those chemicals into our homes, our pets track those chemicals into our homes, our sneakers do, outdoor pet mosquito spraying. This is pretty popular right now. Tick services, personal care products actually have pesticides. They're antibacterial and they're intentionally added to many products to prevent bacterial infection or spread from products to products and over time. Cleaning products, triclosan is one of the big ones, and other antimicrobials. So we get these exposures through cleaning products, hand sanitizers and wipes, such as triclosan again, and many, many others. And even products like flooring. When we redid our bathroom, our tile, the offerings at one of the big box stores was, hey, we've got antibacterial chemicals built into the tile sealant, which is rather crazy, but I wanted to show the variety of exposures. Okay, so pesticides in drinking water. This is an image that Dr. von Saal and I, who will be speaking later, put into our book, Nontoxic Guide to Living Healthy in a Chemical World. This is one of our key images to show how water contamination with a variety of problematic chemicals happens. So as you can see, we have wastewater waste from manufacturing plants, but also runoff from agricultural environments. We have dead animals that get into our water system, believe it or not. We have fertilizers, and they all make their way, as you can see, not only on the surface waters, into the wastewater treatment plants, which don't remove them. They don't have the infrastructure, but also get into the aquifers. So many, many feet below the soil, many of these chemicals are making their way into our water system. So I wanted to go back. Here we go. This is a very popular product. With the pandemic was an explosion, came an explosion of products to scare the bejeebers out of everybody and to market their products. This was actually at an event at my sister-in-law's house where she was so proud to show me of her product, what she had and was putting all over the place. And I wanted to tell her that this is a real problem in many ways. As you see on the bottom where my thumb is, I'm actually covering where all the active ingredients are, but as well, let me see here. Here we go. Here are the active ingredients on the bottom, or I should say that the inactive ingredient pretty much makes up all of the other chemicals. But as we now know, the inactive ingredients in products, not just the active ingredient, are remarkably harmful. There are many, many chemicals that act as dispersants, that act to help these chemicals get into skin or get into areas, not intentionally into skin, but onto surfaces, into many materials, such as surfaces in homes. And so you can see that the real scare here is that it's not just the active ingredient that may be harmful, it's all of the other inactive ingredients that are the 99.80% here. So triclosan is an antimicrobial chemical that was actually taken out of hand soap back in 2016 due to its risk to harm to human health. There are many others, but of course, there are some that still have deferred ruling. So let me tell you a little bit about triclosan quickly. It's found in 93% of liquid soaps, or it was before it was required to be taken out, about 40% of soaps overall. So it is still allowed in bar soaps, hand wipes, many of the products that we're now using actually during the pandemic. It's readily absorbed through the human skin. It's been found in serum, breast milk, and metabolites of triclosan have been found in 75% of Americans. So we know that triclosan, although it was taken out from one set of products, really has made its way not only into our products around the world, but particular into our bodies as well. This was a recent flight I took. As you can see, there is the active ingredient on the bottom left part of your screen, which says 65%. Ethyl alcohol, which doesn't sound so shocking, but when you look over at the inactive ingredients on the right, there you go, triclosan. I even had a woman who follows the Smart Human, my platform, when I posted this, say, hey, you were on my flight, you gave me a card, and I'm going to talk to my union. So I thought that was pretty interesting, how much community work can do on social media. And you can see the triclosan right there on the bottom there. So pesticides in human health, we know that pesticides can cause a great deal of harm. And Dr. Saal will be talking about how this actually happened, how we get these pesticides even on the market. But I want to talk about some of the things you may or may not know. Certainly acute injury. If you have exposure to pesticides in your skin, you can get a rash. And it can really look quite ugly and much like a burn in many cases, depending on the pesticide. But there's also ingestion of pesticides by accident. There's eye exposure that can affect vision. And then, of course, lungs and asthma exacerbation and allergies due to that lung exposure. So there's a lot of different ways that acute injury happens. Chronic exposure is quite different. In many ways, we know that there's an interaction not only between the environment, but also between our genetic setup, our genetic makeup. There are many studies showing links to associations with Parkinson's, Alzheimer's, I'm going to show you a few, and also lower IQ in children, ADHD, autism spectrum, issues with newborns. Of course, cancers, certainly hormone sensitive cancers, as well as with glyphosate, the non-Hodgkin's lymphoma case that won millions of dollars not that long ago. And of course, bacterial resistance is a real risk because as we're exposed to so many pesticides, which are antimicrobials, it can also change our ability to fight infection when we actually need an antibiotic to actually work. In terms of neurodegenerative diseases, I wanted to point these out since many pesticides are designed to be neurotoxins. Alzheimer's is the #1 neurodegenerative disease in the United States, but genetics account for about 70% of the risk, it's estimated, particularly due to, in large part, ApoE4 genes. Now, Parkinson's disease is a little different. It's the second most prevalent neurodegenerative disease. But it accounts for about 10 to 20%. Accounts for genetics accounts for about 10 to 20% of the risk. These are some of the genes that have been identified. So that really means that about 70, 80% of exposure really matters to the development of Parkinson's disease. And this is again linked to associated strongly with chemical pesticide exposures. But please keep in mind, all of the neurodegenerative diseases, along with a lot of other chronic conditions, are likely caused by a complex interaction of genetic vulnerabilities and environmental insults. And Dr. Saal and I talk a lot about how to prevent as much as we can or reduce exposures to what we can control, which are the environmental insults. The gut microbiome is an avenue by which many pesticides make their way into the human body. And I think this warranted just a quick slide to show how important the gut microbiome, the intestine, is to every other part of the body in terms of not only pesticides consumed through food, but also drinking water, as I mentioned. It certainly can predispose to food allergies. That is quite pervasive, as we know, infectious agents, but also the brain-gut connection is incredibly important. And we need to really think about protecting the gut from many of these exposures in order to keep the rest of the body healthy. And just a few things, ideas to note about the gut microbiome, in case you don't know, trillions of microbes live happily, healthily in a healthy organism. 24 feet of bowel in an adult, about 22 feet in a newborn or a toddler. So we have a lot of bowel that's smushed all together there like an accordion. But we hold about 3 to 5 pounds of bacteria in the human gut, which is pretty extraordinary. And the gut manages, it's the largest immune system in the body. And as I mentioned, the gut-brain connection. So it's really quite important to think about the gut microbiome when you're thinking about making changes to your lifestyle, and exposure risk. Residential exposure to pesticides. I thought this was quite an important slide. It was a study that was a meta-analysis looking at exposure inside the home. And children, the conclusion was, based on this study, that children exposed to indoor insecticides have a higher risk of childhood hematopoietic cancers, that's leukemia and lymphomas, and that children exposed to insecticides inside their home have a 47% increased risk for developing childhood leukemia and a 43% increased risk for childhood lymphomas. So we should really be considering bug sprays and animal flea and tick collars and some of the stuff that we intentionally, fumigation, bring into our home. Now, this was a study from the Chamacos. This looked at migrant farm workers and really looked at the IQ in 7-year-olds, both prenatally and postnatally. And researchers found that prenatal, but not postnatal, urinary DAP concentrations, which is a metabolite of organic phosphate pesticides, were associated with poor intellectual development in 7-year-old children. And just to reiterate the component of environment with genetic predisposition, in most cases, Parkinson's disease onset is probably triggered by a complex interplay of many genetic and non-genetic factors, each of which conveys a minor increase in the risk of disease. So glyphosate usage in the US, I want to jump to this. We now see an explosion of glyphosate despite all of the lawsuits that are still coming down the pike. As you can see, it's been a huge growth since 1992 to 2013, given this picture. I thought I'd share a picture of my backyard to give you an idea of my field that is not owned by me, that is directly next to my home and has been sprayed with glyphosate for about 20 years. Until recently, when I communicated and really got to know my local farmers. And we've been really communicating to the point where he did not spray glyphosate. So here we go. A few days ago, I found a truck in my backfield. This is not my land, but next to my home. And they were spraying. And I had to find out from the farmer what they decided to go with. And it turns out it was Zydua. SC, which sent me down a rabbit hole for 24 hours of panic to try to figure out what was sprayed so close to my home and especially next to my kids' bedrooms. And as you can see from previous discussion, we have 41% of what's considered the active ingredient, 58% is the inactive ingredients, things that we are never privy to know since we are the consumer and is not their obligation to share with consumers. This was actually a one application, could not be sprayed more than once, and my farmer did not know that. So I had to educate my farmer that this was a one and done situation, and we'll be seeing if this is sprayed next year after I figure it all out. So now I want to leave you with some practical information. In terms of recommendations, among all of these, I do recommend removing shoes to not track in chemicals from outside, wash your pet's feet, really vacuum quite a bit, and use a HEPA filter regularly amongst the recommendations that are very practical and usable. These are two books that Dr. Saal and I have written together. One is a textbook, and the recent book, Nontoxic, is part of the Dr. Weil Healthy Living Guides, so that you can check all of our recommendations out for a variety of chemicals in your lifestyle. And also, if you choose to follow The Smart Human on Facebook, Twitter, Instagram, and the podcast, that is an environmental health platform. So I will now send this over to Dr. Vom Saal, who is going to tell us how we got into this pickle.
Well, it's a pleasure to be able to provide some additional information to Dr. Cohen's talk. And I'm going to focus on what we talk about in much more detail in our book, Nontoxic. That is, how could these chemicals that are clearly causing harm, causing adverse effects, be considered safe? And one of the reasons is that they're declared to have a threshold below which there are no adverse effects. And this is based on testing one chemical at a time. Of course, we're exposed to multiple chemicals at a time that by law, if they operate through the same kind of response system, they're supposed to legally be required to be looked at as a class of chemicals. And the EPA and FDA just simply ignore the law and don't do that. So they ignore additive effects of chemicals that should be considered together rather than independently. The other thing is that they're adding, in many cases, if they're endocrine disrupting pesticides, to endogenous hormones that are already operating above a threshold. And it's been demonstrated experimentally that when a system is above threshold already, adding a chemical to it changes the system without a threshold dose. I mean, so the concept of a threshold is just simply false for the way it's used by the EPA. The other thing is that this 1500s idea of more is always worse, the dose makes the poison, may seem logical, but in fact, for hormones, it doesn't happen. It turns out that small amounts of a hormone stimulate the response system to the hormone in cells and make the cell hypersensitive to the hormone throughout the remainder of life, if that happens in a fetus or a newborn. And then a very high dose has exactly the opposite effect. It shuts down the system. It's a self-regulating system. So high dose testing, which is all that's done in toxicology testing for risk of harm, then that does not predict what goes on at low doses if this is an endocrine disrupting pesticide. One of the important things about testing low doses is that a single molecule that acts like a hormone can cause thousands and thousands of changes in the cell. There's this tremendous amplification that goes on. Hormonal systems are meant to be triggered by a very small amount of hormone, and then there's a very large effect to it. And this is completely ignored in chemical risk assessments. So the final thing is that there are a bunch of bizarre criteria that were established in order to, I think, by chemical industries, have experiments not be able to be used for risk assessment. If the experiment doesn't have a set number of animals in it, then it's rejected as being acceptable for risk assessment. The problem is a fixed number of animals violates NIH animal use guidelines that say the smallest number of animals is required. The other thing is they require males and females to show the same effects in order to consider an effect adverse. But there's a women's health initiative at National Institutes of Health with the clear understanding that males and females have different physiology. So this is really just meant to be used as a criterion to eliminate findings that are not wanted by chemical industries. And the other really terrible part of current risk assessment strategies, they're not looking at the long-term effects of fetal and infant exposure, where there's a lifetime consequence of exposures. And instead of just studying acute toxicity, you need to look at developmental effects and lifespan consequences. So these are some of the reasons that pesticides that should not be on the market and are causing harm are allowed to stay on the market because of flawed assumptions underlying risk assessment. Thank you.